Hello and welcome to next session of machine learning course. Today I'm going to discuss about KNN algorithm. KNN was born on 1951 by group of armed forces. Two officers of USAF School of Aviation Medicine wrote a technical report in 1951 introducing the KNN algorithm. KNN, also known as the K nearest neighbor, is a supervised and pattern classification learning algorithm which help you find which class the new input belongs to when K nearest neighbor are chosen and distance is calculated between them. The question is, how does KNN works? The KNN neighbor algorithm stores all the variable or available data and classifies a new data points based on distance function. For example, here suppose there are two classes, class A and class B, and we have a new unknown data points, is yellow color symbol. So this data point will lie in which of these classes. To solve this problem, we need a KNN algorithm. With the help of KNN, we can easily identify the class of particular dataset. The data point is classified by a majority vote of its neighbor, with the data points being assigned to the class most common amongst its K nearest neighbors, measured by a distance function. So, how do we choose the factor K? In best practice, choose the value of K where the K equal to N, number of sample in training data set. Error rate and K value. To select the kth right for your data, we run the KNN algorithm several times with different values of K and choose the K that reduces the number of error. If you look at this picture, it is exactly shows what I mentioned. So if you look at this example, this diagram below represent another representation is way you can select K value. In this example, the right K is 37. So let's focus on distance metrics in KNN. The most common types of distance measures are mentioned here. Euclidean distance, Manhattan distance, and Minkowski distance. Minkowski distance is typically used with P being 1 or 2, which correspond to the Manhattan distance and the Euclidean distance respectively. The figure is shown Euclidean and Manhattan distance. The blue line illustrates the Euclidean distance between the green and red dot. Otherwise, you can also move over the orange, green, and yellow line from the green point to the red point. The lines correspond to the Manhattan distance. The length is equal. Here we are going to show how the KNN algorithm works. We are going to show some steps that you need to follow for KNN. Step 1. When implementing an algorithm, you will always need a data set. So you start by loading the data. Step 2. Initialize the value of k. K can be any integer. Step 3. Do the following for each test data. 3.1. Use Euclidean distance, Hamming or Manhattan to calculate the distance between test data and each row of training. The Euclidean method is the most used when calculating the distance. 3.2. Sort the calculated distance and indices from smallest to largest by the distance. 3.3. Pick the first k entries from the sorted collection. 3.4. Get the mode of the k labels. 3.5. Return the predicted class. It means that based on the most appearing class of these rows, it will assign a class to the test point and return the predicted class. And last step is, step 4 is end. Let's talk about the features of KNN algorithm. The KNN algorithm has the following features. KNN is a supervised learning algorithm that uses label input data set to predict the output of the data points. Another feature, it is one of the simplest machine learning algorithms, and it can be easily implemented for a varied set of problems. It is mainly based on the feature similarity. KNN checks how similar a data point is to its neighbor and classifies the data point into the class it is most similar to. Unlike most algorithms, KNN is a non-parametric model, which means that it doesn't make any assumption about the data set. This makes the algorithm more effective since it can handle realistic data. Another feature is the laziness of algorithm. KNN is a lazy algorithm. This means that it memorizes the training data set instead of learning a discriminative function from the training data set. The last feature, the KNN can be used for solving both classification and regression problems. The main disadvantages of KNN algorithm is that this algorithm gets significantly slower as the number of examples and or predictor or independent variable increase. And it is one of the drawbacks of KNN algorithm. So we are going to implement KNN in Python. KNN classifiers in Python. We mentioned that the neighbors is a package of the scikit-learn or scikit-learn module, which provides functionalities for KNN. The classes in scikit-learn neighbors can be handled both NumPy array. We have one example here. The example classification an artificial data set with 3 classes. First, we have to create a synthesis data set. We will artificially create a data set with 3 classes to test the K and N classifier. We call K neighbors classifier from scikit-learn neighbors. For visualization, we use this code. If you look at from sklearn.dataset import make blobs, then import numpy as np. So you just created one artificial data set. This is not the real data set, the artificial data set, and with number of exact sample. To split the train and test data set, we use the training test split from scikit-learn package and use 80% of dataset for training and 20% as a test dataset. So in this section, we are going to create artificial dataset, and after I run this cell and print the input data, you can see the input data generated and the label data also mentioned to this in 3 class randomly 0, 1, 2. In order to visualize the data set, we use this code: import matplotlib.pyplot as plt. We want to visualize these 3 classes with green, red, and blue. Just remember, you have to put some legend, and after I run this one, you can see these 3 classes randomly distributed to x and y axis. So after this, it's time to split the data. Splitting means that you can split to training and testing data. Many people use 70% training, 30% testing. Some people use 80% training, 20% testing. And some of them use 50% and 50% testing. It's up to you and it's up to the result that you want to get. So in this section, I just use training data set, testing data, training label, test label. And I put in training test split. 80% training I choose and 20% test I selected. After I run, now it's time to classification with ANN. Now our data set is ready. We do some pre-processing in terms of training, testing, cleaning, and now it's time to create and feed a nearest neighbor classifier. In order to do that, you have to use from scikit-learn neighbor import k-nearest neighbor classifier. Put in the knn variable and fit to train and testing label and use the predicted knn.predict the test data. After I run this section, they can predict. You see, predicted from the classifier, predicted from target values. So how we make sure the result is correct? There are few metrics to calculate the efficiency of model. The most common for classification is accuracy. That classification accuracy is the metric that summarizes the performance of the classification model as the number of correct prediction divided by total number of predictor. Based on this formula, you see, accuracy equal to the number of corrected prediction divided by the total number of prediction. So it's time to recover accuracy score, predicted and test label. So after you run, the accuracy is 1. Means that it is easy to calculate and intuitive to understand, making it the most common metric used for evaluating classifier model. The accuracy for this model is 1. It means that 100%. But in many real applications, it's difficult to reach to accuracy of 1%, 100%. Here is another example of KNN in real data set, IRIS data set, using scikit-learn library. The data set information can be available in public data set. The data set consists of 50 samples from each of 3 species of iris flower, Cetusa, Virginissa, and Versicolor. 4 features were measured from each sample: the length and the width of the sepals and petals in centimeters. You see, sepal is here, petal is there, and the class label is target. This is already the algorithm with label data, because we are talking about supervised learning. Now, after description of this one, we are going to implement and load the data. Load the data and implement it. Let's have a look. First, you have to load the IRIS dataset. Here, the dataset already loaded. Let's see. And we already print IRIS feature name. After you load, they put a feature name, spall length, spall width, petal length, petal width. And IRIS target. The target is categorized in 3 classes. Then we print the IRIS data, the 5 recorded, this one, based on the value that we got. And we also going to print the target name. Here, you see the target name. Here, data and label equal to IRIS data and IRIS target. We already got it. Now it's time to split the data to training and testing, like the previous one. We already split 80% training, 20% testing. Now it's time to show in the shape 1, 120 for training, 30 for the testing. Total is 150 data. Now it's time to create and fit a nearest neighbor classifier. Like the previous one, you can run the K nearest or neighbor classifier, and now it's time to show the result here. Prediction from the classifier. Here, what they predict. You see, most of them are predicted correctly, but we have to use the accuracy score to make sure how many percent our KNN already corrected. So after you predicted, it's time to use KNN and finding the optimal K value. Sometimes you have to find the optimal K value. You have one error rate equal to bracket empty. You put one loop for A in range 1 to 40. Do this coding in order to plot the error rate and find the best K value. Here, the error rate should be up here, like the previous one. And I hope you enjoy and find the best accuracy based on the K value.